For number 26 and 27, our last two problems for the review, we are solving initial value problems. So we're asked to find the original function f if we know that the derivative of that function is 6x squared minus 12x, and then we also know that if a 1 goes into that function as input, we get a 3 out as output. So we want to integrate the derivative. We're going to go back to finding that original function, so we're going to integrate with respect to x. Notice that this is an indefinite integral. We're not asked to integrate from a certain x value to another x value. So this is the indefinite integral, and we will need to include our constant of integration. So let's integrate each term separately with respect to x. I'm going to go ahead and bring the constants out for each of those terms. And I get 6 times, add 1 to the power, divide by the new power, minus 12 times, once again add 1 to the power, so it's already 1, so we're going to add another 1, so we get x squared, divide by the new power, and then we'll include our plus c, that constant of integration, since we're dealing with an indefinite integral. So let's simplify a little bit. So we know that our original function f would look like 2x cubed minus 6x squared plus some constant c. Remember, to actually figure out the constant, that constant of integration c, we actually have to use the information here that we're given, f of 1 equals 3. So if a 1 goes in to our function as input, the 3 should come out as output. So we're going to take our function, we're going to put in a 1 everywhere that we see an x. We don't know what the constant is, so we're going to leave c as c. But we do know that if we put a 1 in, that the result as output should be a positive 3. So we're solving this problem for c. So let's simplify the left side here. 1 cubed is 1, so 2 times 1 is 2. 1 squared is 1. Negative 6 times a positive 1 is negative 6. And we get a really simple equation here to solve. Negative 4 plus c equals 3. We're going to add 4 to both sides. We get c equals 7. So now we know that the original function f has to be 2x cubed minus 6x squared plus 7. All right, number 27, we're asked to do the same thing. We're asked to solve the initial value problem. If we are given the derivative of the original function, so we're told that f prime of x is equal to 3 times e to the x minus 10 times x. And we're also told that if a 0 goes in place of x, that a 10 comes out as output for y. So since this is the derivative, we want to find the antiderivative. So we're going to integrate that derivative with respect to x. Once again, this is the indefinite integral. We're not given an upper and lower limit of integration, so we will have to put in our plus c. So let's take the separate terms, so let's break them up into two separate integrals. So for the first term, I'm going to bring out the constant 3, and we're going to integrate e to the x dx. For the second term, I'm going to bring out the constant of negative 10. I'm going to integrate just x dx. So now let's actually perform the integration. That would be 3 times the antiderivative of e to the x is just e to the x, minus 10 times, so we have a 1 already, we're going to add a 1 to that, and then we're going to divide by the new exponent, plus c, so we don't want to forget our constant of integration when we're dealing with indefinite integrals. So what we're saying here is that the original function has to look something like this. 3 times e to the x minus 10 divided by 2, we're going to write that as minus 5 times x squared plus some constant c. In order to figure out what that constant is, we need to use that extra piece of information that we were told, that if a 10 goes in place of x, if a 0 goes in place of x, then a 10 comes out on the other side in place of y. So we're going to put the 0 in everywhere that we see an x. So it's 3 times e to the 0 power minus 5 times 0 squared plus some constant. And we know that the result of putting that 0 in has to be an output value of 10. So we want to say what c has to be in order to make this true. Remember that any base raised to the 0 power is 1, so that's 3 times 1. 0 squared is 0. So what we have here is 3 minus 0 plus c has to be equal to 10. So 3 plus c equals 10. When I subtract 3 from both sides, we get c equals 7. So now we know the original function would have to be 3 times e to the x minus 5 times x squared plus c, which we know now is 7. So this is the original function that has the derivative that we were given, and also if a 0 goes in, 10 comes out as output.